Hello there, this is a financial mathematics video looking at depreciation. Depreciation occurs when a value decreases by a certain percentage and then that lower amount is decreased by the same percentage and so on, year after year. Depreciation is a bit like compounding, but it's not growing on itself, it's sort of losing value, so it's in reverse sort of, but is related to compound interest. Now we have depreciation possible to calculate by repeated multiplication. Let's have a look at an example. A motorbike, which was originally worth $16,000, loses value at a rate of 8% per year. How much, this question asks, will it be worth after 4 years? So if it loses value, it's kind of decreasing by a certain percent, in this case 8% per year. So let's remind ourselves of percentage decrease. To decrease by a certain percentage, we multiply the number that's decreasing by 100% minus the amount of the percentage decrease. So in this case, to decrease by 8%, we can multiply by 100% minus 8%, or multiply by 92%. So if we multiply by 92%, we'll get an amount in our answer that is 8% less than the original. So it's easier to work in decimals, so we'll multiply whatever is going to decrease by 0.92 in decimal form. So we'll keep that in mind. And we'll take our $16,000 from the example and we'll multiply it in the first year by 0.92. So that will be a smaller amount then for that answer, and then we'll take that answer and in the second year we'll multiply it by another 0.92, so it'll get even smaller, and then we'll take that answer and multiply it in the third year by 0.92 and in the fourth year by 0.92. So it's almost like we get a smaller amount after 1 year. It's reduced by 8%, and then that smaller amount is reduced by 8% again each subsequent year. So it's important that the calculations take place on the reducing balance. So we're not calculating it always on that $16,000. We only did that in the first year. Each time we're calculating it on the reducing value of the motorbike each time. So if we type that into our calculator, we'll discover that the answer is 11,462, which represents to the nearest dollar that the motorbike has lost a lot of value. It's now worth $11,462 after the 4 years. So it's reduced in value each year and continued on like that. So that's depreciation. It's losing value by repeated multiplication, and it's by decreasing it by a certain percent. Okay, now there's a depreciation formula, a bit like the compound interest formula, but it works in reverse a little bit. Instead of a plus here, the compound interest formula had a plus in between the 1 and the R. This one's got a minus to illustrate or represent that we're going down in value here. But I'll show you the similarities between these two approaches here. They're kind of the same thing in the end. Let's have a look at the parts here. The A in the depreciation formula actually represents the final value of the item. So that's how much it's worth after all that depreciation has taken place. P stands for the principal, or the original amount invested, or in this case the original value of the item really. R is not an interest rate as such, but it's a rate of depreciation per compounding period, and we express it in decimal form. I'll show this in an example, it'll make a bit more sense then. And N is the number of compounding time periods. So let's have a look at an example then. Well, this same example really, following the depreciation formula process rather than the repeated multiplication process. So our principal, or our original value really, was $16,000 from the question up there. So we'll put that in for P. And then we'll keep it going here. We'll have the bracket there and then a minus. And then we want the rate at which it's depreciating, in this case 8%. So we put that in decimal form. It's reducing by 8%, which in decimal form is 0.08. And the N is the number of periods we have, and this is 4 years. It's depreciating once a year for 4 years. So if we type that into our calculator, Well, we can actually simplify a bit. The bracket here, 1 minus 0.08 is actually 0.92. So we could type that into our calculator, but I just wanted to highlight before we do the calculation, let's have a look at just this bit here. 0.92 is being multiplied by 16,000, but it's 0.92 to the power of 4, which really means 0.92 times itself times itself times itself. So I want you to compare this bit here in the depreciation formula to this bit up here, because you can see how they are equivalent. We've got $16,000 out the front of both situations, and can you see that 0.92 to the power of 4 is just a shorter way of writing 0.92 times 0.92 times 0.92 times 0.92. So they're equivalent. So really, in the end, they're working it out the same way. They're just this way is just like a summarized version, a shorter way of expressing the same calculation. Alright, just wanted to point that out for you. And we get, lo and behold, the same answer. The motorbike is now worth $11,462 like it was before. So we really, the depreciation formula is just a shortened, summarized version of that repeated multiplication method that we had before. So the value of the motorbike is reducing year after year, and it's calculated on the balance it was at the end of the previous year, not the original balance really. So that's how depreciation works, either by repeated multiplication or the depreciation formula. So we can depreciate either way. We can multiply by a decimal that will reduce it by a certain percent each year, or we can use the formula for a bit of a shortcut if we want to. So that's depreciation. I hope that helps a lot. peterblakemaths.com. We'll see you again.